Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, my friends, we're going to talk about solving single-step equations. Very simple. As I had promised, I'm going to take you step by step through this section. And I don't want to just cram it all in one day. So if you have any questions, please ask, please focus. It all starts here. Okay? All equations will build on this first single-step type of equation. So please make sure that you understand everything that we're about to talk about. First of all, the goal. The goal is to isolate the variable. That means get the variable all by itself. If you're solving for x, y, z, w, k, it does not matter. You want to isolate the variable. The variable wants to be alone by itself. Okay? Now, what does that mean? What does that look like? It looks like this. You want to solve for x over 1. X over 1? What are you talking about, Morrow? I want to make sure that you guys understand that I'm solving for x in the numerator. For example, if you have 1 over x equals 9, that is wrong. The x in the denominator. That is not what we're solving for. We're solving for x equals 9. Okay, Maura, I get that, but why did you put that 1 there? I want you guys to realize right now, from the beginning, and keep this forever. Every number and or variable is being multiplied by an invisible 1, divided by an invisible 1, and raised to an invisible first power. So all I'm saying here, you don't have to put, w over 1 equals 6. All I'm trying to portray to you guys is that x is in the numerator. We're solving for x, not 1 over x. We're not solving for negative x. We're not solving for 3x. We're not solving for 0.3x. I'm not trying to be sarcastic at all. We're solving for x alone in the numerator. That, believe it or not, is a concept that a lot of kids really don't understand. That's something that hasn't been clearly stated to them. But now it's all set. Okay? For single-step equations, my brothers, it's very simple. First off, it's called a single-step equation because how many steps do you think it has? 1. It's literally got 1 step. And it's going to be one of these 4 options for you guys. If it's x plus 2, for example, equals 9, well, my friends, you undo addition with subtraction. So you look at the x, and you look at the numbers that are next to the x. You say, all right, this is x plus 2. I want to get x by itself. How can I get rid of this positive 2? Addition is undone with subtraction. So you would subtract 2 to both sides, and then x will equal 7. So you undo addition with subtraction. With that same logic, you undo subtraction with addition. So if I were to give you instead x minus 2 equals 9, I have this negative 2 that's being added to the x. How do I get rid of that negative 2? By adding 2 to both sides. X would equal 11 here. Okay? Now if you notice, whatever I do to one side of the equation, I do to the other side of the equation. An equation is literally a balance. It's kind of like if you guys are going to go and do some bench presses. You don't put 50 pounds on the left side and then 12 pounds on the right side. It's not a balanced workout there. If you're going to put 50 on one side, you put 50 on the other side. I want to add 10 more pounds to the left side, then I add 10 more pounds to the right side. It's a balance. So whatever you do to one side of the equation, whether it's a single step, 2-step, or multi-step, whatever you do to one side of the equation must be done to the other side. You can undo multiplication with division. What does that look like? Well, it looks like this. Let's say I have 3x equals 12. That's kind of messy. Hold on. Equals 12. Well, in this case, you always have to ask yourself, what is the relationship between the variable and the numbers given? And in this particular case, since I have a 3 next to an x, and there are no plus or minus signs in between the 3 and the x, that means that the 3 and the x are being multiplied. And I undo multiplication with division. So I'm literally going to divide both sides by 3. And x would equal 4. Okay? And last step for a single step equation, use division to you undo division with multiplication. What does that look like? Well, let's say I have x over 4 equals negative 5. Okay. Remember what I told you about the invisible 1. There's an invisible 1 here being multiplied to that x. So I am going to multiply by the reciprocal. I am going to multiply both sides by 4 over 1. Moro, isn't just multiplying by 4 the same thing? Yes, but I'm trying to articulate to you guys that I'm multiplying 4 to the numerator. Okay? So these cancel, and x would equal negative 20. If you just multiply by 4, sometimes people think it goes to the denominator, and it does not. So whenever you have a division, okay, in a single step, or in multi-steps, once you get down to a single step phase, which we're going to see later on, you always get rid of division by multiplying by the reciprocal. Flip it. And that's literally the lesson. So let's do some practice, guys. Okay, so I got 27 plus n equals 46. What do I do, sir? That's exactly correct. So you subtract 27, so n will equal 19. Excellent. Okay, number 2. How do I solve for q here? Yes, sir. That's right. You got q plus 13. How did I get rid of a positive 13? By subtracting 13. Beautiful, son. So that's going to be as well negative 9 equals q. How about for number 3? How do I get that j all by itself? Yes, sir. You add 3 to both sides. Very good. You undo subtraction with addition. Beautiful. Well done, my brother. How about number 4, guys? How about number 4? How can I get that p alone? Yes, sir. That's exactly correct, sir. You got p plus 7.1, so I'm going to subtract 7.1 to both sides because I get rid of addition with subtraction. And this would be negative 9.6 equals p. All right? How about number 5? What do I do there, guys? Yes, sir. That's exactly correct. I've got y minus 19. How do I get rid of a negative 19? By adding 19. I get rid of subtraction with addition. So y will equal, I believe that's 56. 56. There it is. Okay? Let's go to some multiplication and division ones now, gentlemen. Number 6. The relation between negative 7 and y is multiplication. How do we cancel multiplication? So what do I do, my brother? You divide negative 7 to both sides. Fantastic. So y equals negative 4. Excellent. Okay, I've got 4x here. What's the relationship between that 4 and the x? Are they being added, subtracted, multiplied, or divided? Multiplied. How do I get rid of multiplication? Division. So I'm going to divide 4 to both sides. Fantastic. And that's going to equal negative 24. Thank you very much, my brother. Excellent. Okay, how about this bad boy? What's the relationship between the m and the 7 here? Sir, they're being divided. Good. How do I get rid of division, my man? Not cross-multiply. Very good. I don't want to train you cross-multiply. It's going to get you confused later. Which you are cross-multiplying here, so you didn't say anything wrong. I just want you to get into the habit of multiplying by the reciprocal. Because if it was 2m over 7, you can still do it by cross-multiplying, but it's going to be a little bit of a pain. Okay? So the 7s cancel, and m would equal 84. Okay, how about number 9? How do I get that k alone? How do I solve for that k? Yes, sir. That's right, you're going to multiply by 4 over 1 to both sides. Guys, remember your simple math. Remember how to cross-reduce. 2 goes into 2 one time, 2 goes into 4 2 times, so k equals negative 34. And last but not least, what's the relationship between that 2 and that x? Multiplication. How do I get rid of multiplication, my brother? You divide. So what am I going to divide here by? by 2. Bing, bang, boom. There you go. X equals negative 12. Does that make sense, my brothers? Pretty simple, right? Awesome. Awesome blossom. Okay, so let's practice real quick. I think I could finish this before the bell. Yeah, we could do this. Okay. Now, a little bit more complicated here. What's the relation between that 2/3 and that x? How do I cancel multiplication? Division. Wait a second. Division. Very good. Remember that when you divide fractions, guys, I don't know if you remember, but it's stay, change, flip. The first fraction stays the same, change the multiplication, and then you flip the second fraction. Now that's going to be a lot of work for you to do, so what I would suggest, okay, when you want to get rid of a multiplication of fraction, literally multiply by the reciprocal. So you multiply by 3/2. The 3's will cancel, the 2's will cancel. I'm left with x equals. Let's cross reduce. Remember that 18 has an invisible denominator of 1. 2 goes into 2 one time, 2 goes into 18 9 times. 9 times 3 is 27. Okay? Number 2, 3/4 x equals 9. I have a multiplication of a fraction, so I'm going to multiply by the reciprocal of 4/3. Cancel, cancel, x equals, cross reduce. That goes to 3. Remember, there's a denominator of 1. 3 times 4 is 12. I'm going to pause this video for a second, guys, because the bell's about to ring. I'm going to finish this, though, so you can watch it at home. Remember, the 1-3 part 2 homework for today is valid, okay? And we'll double up on this quiz for part 1 and 2. Thank you very much. Have a great day. Okay, guys, so number 3, 2/5 x equals 4/7. Again, I have a multiplication of a fraction to a variable, so I get rid of that multiplication by multiplying by the reciprocal. I'm literally dividing 2/5 to both sides. So I got to stay, change, flip, and I multiply by the reciprocal. Cancels, x equals, cross reduce. That's going to be 10/7, which could equal 1 3/7. Okay? Number 4. Now, before you start doing number 4, please realize that you cannot multiply or divide mixed numbers. You must first turn it into an improper fraction. So 3 times 2 is 6 plus 2 is 8/3. X equals 12/15. Multiply by the reciprocal to get rid of that 8/3, which is being multiplied to x. The 8/3 cancel. X equals, let's cross reduce. 4 goes into 8 2 times. 4 goes into 12 3 times. 3 goes into 3 1 time. 3 goes into 15 5 times. So I've got 3 times 1, which is 3, and 5 times 2, which is 10. So I've got 3/10. Number 5. Okay, I have 1/3 plus a. Okay, so I'm going to subtract 1/3 to both sides. So now, please remember how to add or subtract fractions. I need a common denominator. My common denominator here is going to be 21. So what do I have to multiply to 7 to get to 21? If you said 3, that's great. Remember that whatever you multiply to the denominator, you must multiply to the numerator. So that is 6/21. How do I get from 3 to 21? By multiplying by 7. Remember that whatever you multiply to the denominator must be multiplied to the numerator. So I've got negative 7/21. 6/21 minus 7/21. When the signs are opposite, you subtract as normal and keep the sign of the largest absolute value. So a will equal negative 1/21. Number 6, x minus 4 2/3 equals 2 2/3. Well, I got to get rid of that negative 4 2/3 by adding 4 2/3 to both sides. You can add and subtract mixed numbers. You just cannot multiply or divide them. So x will equal 6 4/3. but this 4/3 is 1 1/3, so I add that one whole number to the 6, becoming 7 1/3. Negative 5.3 plus y equals 8.9. So I get rid of subtraction with addition. I get rid of a negative with a positive. So I add 5.3 to both sides. And y equals 2. Bring the decimal, carry the 1, 14.2. And last but definitely not least, I have h plus 2.8 equals negative 3.7. I get rid of a positive with a negative, so I subtract 2.8 to both sides. H equals negative, I got 5, carry the 1, that's going to be negative 6.5. And that is how you work with single-step equations. I hope that made a lot of sense. Hope you learned a lot, and I wish you a great day. Thank you very much. Bye-bye.